Okay, so today we're going to talk about trig inverse values with the calculator. This is day 2, so we've already done something pretty similar to this. So when we talked about this before, we talked about how sine of theta equals 7 over 9. So what that says is that sine of an angle is equal to the ratio 7 over 9. Well, if you know what the ratio is, 7 over 9 is the ratio, then we must be solving for the angle here. And so you have to get rid of the sine by doing sine inverse. So we say theta equals sine inverse of 7 over 9. And if you type that into your calculator, sine inverse 7 over 9, notice that since we see a theta here, we must be in degrees. So make sure your mode is in degrees. And sine inverse 7 over 9 is equal to 51.058, rounded correctly. Oops. 51.058. Remember that that's the angle, so I'm going to go and put that in degrees. So once again, just to recap, what we just concluded is that sine of 51.058 degrees is equal to 7 over 9. Alright, so what would we put into the calculator to find cotangent of 51 degrees? I do see a degree symbol, so there I'm in degrees. And cotangent is one of those things I don't have a button for. So in order to put that into my calculator, I have to relate it back to the reciprocal, which is tangent. So I'm going to type in 1 over tangent of 51 degrees. That's how I type that into the calculator. So the approximate value of that, 1 divided by tangent 51, is 0.8097, rounds it to 0.81. So it's approximately 0.810. So what did we just find? Did we find the angle or did we find the ratio? So go back to the problem. It was cotangent of the angle, so what that's going to equal is the ratio. So that was the ratio. Okay, what do we put into the calculator? Find cosecant inverse of 1.4. Once again, we don't have a button for this, and what we talked about on Friday is that if you see that little -1 thing, in order to change that to its reciprocal, you have to flip the thing inside the parentheses. So how we're going to put this in the calculator is relate it back to sine inverse of 1 over 1.4. So sine inverse of 1 over 1.4 is 45.585. So that's approximately 45.585. And that's the angle that creates that ratio. So this was sine inverse of 1 over 1.4. What we found was the angle that created that ratio. So that's why this is an angle here. So this is just a quick reminder, when do you flip what? So obviously if you have a button, you use the button. But when you don't have a button, you do 1 over the whole thing if there is no -1, and you do 1 over the inside when there is a -1. Alright, so sine of 62 degrees. So sine of 62 degrees. I just typed that in because there's a button for sine, so that's 0.883. So what we found is the ratio of sine of 62 degrees. 1 over secant of 51. I don't have a button, so I'm going to have to relate it back to cosine. So 1 over cosine of 51 is 1.589. And cotangent, I don't have a button, so 1 over tangent. Is 2.605. Okay, alright. Now the bottom, find the angle, and it's going to be in degrees if you see the theta, and it's going to be in radians if you see an X. So this says find the angle in theta degrees or X radians. So we have cosecant theta equals 3.1. So we must be in degrees here. And keep in mind you're trying to solve for the angle. So if you're trying to solve for the angle, I need to get the angle by itself. Like in algebra, get the variable by itself. So I will cosecant inverse both sides. Well, now I say I don't have the button for cosecant. I see the little -1, so I must be flipping this inside. So theta equals sine inverse of 1 over 3.1. So sine inverse 1 over 3.1 is 18.819. So theta equals approximately 18.819, and this was in degrees. So what that says is that if you were to type in cosecant of 18.819, you should get the ratio of 3.1. Alright, tan x. Oh, so keep in mind here, if I see an x, this is in radians. Go ahead and change your calculator right now to radians. So mode radians. But we still need to solve for the variable, and the variable in this case is x. So get x by itself by taking tan inverse on both sides and 1.2. I do have a button for tan inverse, so I'm just going to type that straight in. Tan inverse of 1.2. So x is 0.876. So x is 0.876. I'm going to go ahead and write radians because this is telling me that 0.876 is the angle. I know it looks weird as an angle, but it looks weird because it's in radians. But this is the angle in radians that creates this 1.2 ratio. It's really important that you keep in mind what it is that you're solving for. Are you solving for the angle or the ratio? Alright, and then theta equals cotangent inverse. So go ahead and see if you can do this one. Push pause. I'm going to go ahead and do this. So theta equals tan inverse of 1 over 1.8. So theta is approximately, I am in degrees because this is theta, tan inverse 1 over 1.8. 29.055 degrees. Okay, alright, let's go on to page 2. Okay, page 2. Use the given trigonometric function to find angle theta in degrees or x if it's in radians by using your calculator. And then we're going to draw the special right triangle to check your answer. Alright, so in example 1, cotangent theta, I'm in degrees, so cotangent theta equals 1 over root 3, and I need to be in quadrant 3. Well, first what we're going to do is we're going to satisfy this part. So what I'm trying to do is to find the angle, in this case in degrees, that satisfies this ratio. Then after I find that angle, I'm going to put it in quadrant 3. Keep in mind that if what you're finding first is theta ref, then this is going to be positive. So we will use a positive ratio no matter what. So 1 over root 3 is already positive, so we don't have to worry about it in this case. But if you jump ahead to look at example 2, this is why I'm talking about this. This ratio is negative, so in this first step we would actually change that to a positive to satisfy finding theta ref, which will always be positive. But I'll talk about that again when we get to example 2. So I'm going to find theta ref first by doing cotangent inverse of 1 over root 3. Well, I don't have a button for cotangent inverse, so I'm going to have to change this to tan inverse, and I'll flip that to root 3 over 1. And we all know we don't actually have to put the over 1 if you don't want to. So theta ref, type that in your calculator, tan inverse of root 3 over 1, if you prefer. is 60. Now I'm going to come over here to satisfy that second part. So if I wanted to draw this in quadrant 3, this is my quadrant 3. I draw my reference angle in quadrant 3, and this is 60 degrees. Well, what I'm looking for as a final answer is not that reference angle, but the standard angle that creates that ratio. The standard angle, if you remember, always starts at the 0 degree, and then in this case you want it to end right here. So this is the answer that I'm looking for. So that answer involves going, well, the full 180 and then plus 60 more. So that's going to be theta standard in this case would be 240 degrees. Okay, it does want us to check our answer, so just a real quick check. Let me erase some of this. I don't want to erase all of it. Okay, I'll just draw a new triangle. If I had been originally given... Okay, let's go back and review everything that we just did. Cotangent theta equals 1 over root 3. And we just said that theta equals 240 degrees. So if I plug that theta in right here, cotangent of 240 degrees, what does that equal to? So I can say, well, I know 240 degrees is past the 180 is right here. So this is 60. Across 60 is root 3, across 30 is 1, and across 90 is 2. Both of these are negatives. And cotangent is A over O, so negative over negative does create the positive, which is 1 over root 3, which is what we were hoping to get. So that's just a check. Okay, let's go on to example 2. I'm going to pause this. Alright, in example 2, first thing I notice is I'm in radians, so go ahead and go to mode, go to radians, and we need to solve for x before we start, and this is going to be our reference angle in radians. So x is going to equal secant inverse of negative 2 over root 3. Keep in mind, we're trying to solve for that reference angle, so x reference. Okay, I don't have a button for secant inverse, so I'll relate that back to cosine. In that same step, I'm going to go ahead and drop the negative, because since this guy is always positive, I will use a positive ratio. Then I will satisfy the quadrant. So cosine inverse of positive root 3 over 2. So x reference must equal, so cosine, everybody's in radians right now, that should be true, cosine inverse root 3 over 2. Make sure you're putting that in your calculator correctly. With cosine inverse root 3 over 2, the 2 should be still inside the parentheses of the cosine inverse. Alright, and so I get approximately, let me change this to approximate, 0.524. Now remember that this is in radians, so that probably looks kind of weird to you as an answer, but it is the angle, just as the angle that is in radians. So now if we want to put this in quadrant 2, so I'm going to draw quadrant 2. If this is my theta ref, then that belongs right here, 0.524. And what I'm looking for is from the 0 to that line. So in radians, this is pi. So how I'm going to find from here to here is I'm going to say, well, I didn't go a full pi radians. I'm 0.524 short of that. So in my calculator, I'm typing in pi minus second ANS, and I get 2.618 as a final answer. And this is radians. 2.618. Okay, now I think to check this is really, really important for you to do. So in order to check this, I'm going to draw quadrant 2, and I'm going to try to see how I can make this as my ratio in quadrant 2. So draw quadrant 2 for me. So this is my checking work. So draw quadrant 2, draw your triangle, and if you know that it's supposed to be hypotenuse over adjacent of 2 and root 3, it does make sense that this is negative root 3 since I'm in that negative direction. So this must be 2 root 3, that's a 30, 60, 90, so what's missing is this 1 here. And across the 1 is 30 degrees. Go in radians though. This is 30 degrees in radians is pi over 6. So if that's pi over 6 right here, because it's across the 1, then my standard must have been 5 pi over 6. So my theta standard was 5 pi over 6. Now if you type in 5 pi over 6 on your calculator, you should get exactly what you got before, 2.618. These two things are equivalent. This is just considered the radian using pi's, and this is rounding it off, typing instead of pi 3.14. Actually, I want you to use the button of pi, but you know, approximately 2.618 is 5 pi over 6. Okay, let's go on. We are able to check this answer because the ratios are part of a special right triangle. So what I'm saying right here is if you go back to that example we just did, 2 and root 3, that's part of the 1, root 3, 2, 30, 60, 90s that we are familiar with. Same thing with example 1. 1 over root 3 is part of the 30, 60, 90. But if you look at these next examples, 5 and 4, you don't have that ratio memorized. Or 2 and 3, that's not a ratio that you should recognize. So these we're just going to have to do like only with the first way. We can't check these answers using that special rights that we know. Alright, so theta equals, I'm in degrees, cosecant inverse of negative 5 over 4. All I did there is solve for theta. Now, I'm going to say, well, since what I'm really solving for in this step is theta ref, I'm going to make that a positive ratio. So I am going to make this a positive ratio. At the same time, I know I don't have a button for cosecant, so I'll go ahead and relate it back to sine. And I'm going to say sine inverse 4 over 5. Alright, so if I type this in my calculator, then theta ref is... So make sure your mode is in degrees. Sine inverse 4 over 5 is 53.130 degrees. And now if I wanted to satisfy that to be in quadrant 4, I'm going to change colors. This is quadrant 4. Theta ref is supposed to be 53. This would represent all of 360. I'm 53 degrees short of that. So keep in mind what it is that you're looking for. This is what I'm looking for. So 360 minus that answer is 306.87. Okay, let's go on. Alright, sine x equals 2/3, so we're back in radians. Sine inverse of 2/3. This is, I have a button for that. It's already positive. So x reference, I'm just going to type that in radians. It's kind of annoying to go back and forth, but you do absolutely have to go back and forth. 0.73. So x is approximately 0.73 radians. Now if I'm in quadrant 2, this is quadrant 2, this is 0.73. Now the answer that I'm looking for is how did I get there? So if this is in radians, I didn't go quite pi, I went pi minus 0.73. So pi minus that answer is 2.412. Alright. Now these are just, now you try, so y'all can do that on your own.